Hello, we are discussing about GATE 2004 ECE paper. Look at the two statements given. Find which one is right, which one is wrong. That is, you are going to find which statement is false, which statement is true. So, first statement is at the resonant frequency, the impedance of series RLC circuit is 0. This is false statement. Okay. Series RLC circuit is going to be looking like this. Okay, where V is the voltage and current flowing through it is I. If you are going to check about the impedance, okay, impedance is Z. Z can be written as Z is equal to R plus, okay, J omega L plus 1 by J omega C. So we can write it as R times of, we can write it as R plus J times of omega L minus omega C. Because 1 by j can be written as minus j, so you can take j common. And magnitude of impedance, so going with, at that time it is square root of r square plus omega L minus 1 by omega c whole square. So the curve for this one is going to be looks like this one. Impedance versus frequency. Okay, as omega value is going to be increases from 0. Whenever omega is equal to 0, at that time 1 by 0 will become infinite. So impedance is very large. Whenever omega is equal to infinite, by that time this infinite into L becomes very large. So that will be infinite. So at a point, the resonance is going to be occurring at one point where the inductive reactance is same as capacitive reactance. So at this point, XL at resonance, XL is equal to XC, that is omega L is equal to 1 by omega C. Then you are going to get it as Z is equal to square root of R square, which is nothing but R itself. But it is not 0. You will get the minimum impedance. So at resonant frequency, the impedance of RLC circuit is minimum. If it is given as minimum, then it is true. But it is given as 0. So it doesn't find 0, it will be a minimum. That minimum value is going to be resistance of series RLC circuit. So at this point you will get it as R. So first statement is false. Next come for the second statement. In parallel RLC circuit, even though it is given GLC circuit, G is equal to 1 by R. Okay, so we can write it as RLC circuit or GLC circuit, you can refer the same thing. But G means 1 by R, reciprocal of resistance is G. Okay. So GLC circuit, increasing conductance G results in increasing its Q factor. For parallel RLC circuit, okay, for parallel RLC circuit, QP means quality factor for parallel RLC circuit. Okay, then it is resistance divided by reactance. So that means R divided by omega L or R divided by 1 by omega C, which means omega CR. So omega is resonant frequency. So at resonant frequency, quality factor is defined as resistance divided by reactance. You can define in terms of inductance or you can define in terms of capacitance. So these are the two equations, and we know the value of omega R. Omega R is resonant frequency. Resonant frequency for whether it is series RLC circuit or parallel RLC circuit, it will be same, that is 1 by root LC. So substitute this 1 by root LC in place of omega R either in this equation or in this equation. You are going to get expression for quality factor, which is R times of square root of L by C. This is quality factor of parallel RLC circuit. So now we know the equation. Now we'll go for the whether it is false or true. The given statement for the parallel GLC circuits. As increasing G. Okay. So as G increases, G increasing means R is reducing because G is equal to 1 by R. So as R reduces, what happens to Q? QP is going to be gets reduces. As QP is directly proportional to R, as G increases, R value gets reduces, that means quality factor reduces. But it has given that one, increasing conductance G results in increasing Q factor. Okay, so this is false. Increasing conductance G reduces the quality factor. So the given option is false. Both are false statements, S1 and S2. So the right option for this question is B. Thank you.